Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. In this lecture, we are going to implement Deep Q-Learning in Theano for Cartpole. This simple example is going to let us at least observe Deep Q-Learning in action in a reasonable amount of time. If you don't want to try to code this yourself, although I highly recommend you do, the relevant file in the course repo is dqntheano.py in the subfolder Cartpole. At the top, we have all our usual imports. After that, we have the hidden layer class. This is pretty much the same as before. Next, we have the dqn class. In the constructor, we take in the number of inputs d, the number of output actions k, the hidden layer sizes, gamma, the experience replay buffer size, which we call max experiences, the number of experiences to collect before training, which we call min experiences, and the batch size, which is the number of samples we are going to use to train. First thing we do is set some of the optimizer hyperparameters. You are encouraged to play with these. Next step is to create all the layers. After that, we collect all the params in the network, since this will be useful for copying the main network to the target network and specifying the update rules. Next, we declare the input and target Theano variables. After that, we calculate the output and the cost and the updates. This should all look familiar to you since we've seen them earlier in the class. Again, I recommend testing out different hyperparameters and different optimizers. Next, we create the replay memory. This is one way of doing it, but I'll show you another way later. We also need to save some of the inputs as instance variables for later use. Next, we have the copy from function. This will copy all of the params from the input network to itself. This is why we wanted to keep track of all the params earlier, because now we need to loop through them, get their values, and assign them to the corresponding param in the other network. Luckily, Theano has handy functions, getValue and setValue, that help us do this. Next, we have the predict function, which you've seen before. And after that, we have the train function, which you have not seen before. First, if we haven't collected enough experience, we just return without doing anything. Otherwise, we select a set of random indexes equal to the batch size. Next, we index the experience dictionaries to get the state, action, rewards, and next states. We then use the next states to calculate the Q targets. Notice the use of the target network here. This also explains why we needed to pass in gamma earlier. Finally, we call the train op with this data. In a later lecture, you'll see a more compact way of sampling the batches, but it's less straightforward to parse. Next, we have the add experience function. This just adds the for tuple of the state, action, reward, and next state to the experience list. Finally, we have the sample action function, which is the same as before. Next, we have the play1 function. This is almost the same as before with some minor changes. In the section of the code where we update the model, we also add an experience. The train function now only takes in the target network as an argument, since all the data is stored in its experience buffer. And we also use the argument copy period to tell us how often to copy the main network to the target network. Next, we have the main section. This is largely the same as before, except of course now we are creating a dqn, which has some different parameters. So let's run this and see what we get.